Hello everybody and welcome to a new video. This is the fourth video of the Weather Monitor project. In the first video, we set up our sensors and our programmable board. In the second video is where we connected our weather station to a local MQTT broker. And in the third video, we started saving the data to a database using Python. In this video, we will use this data to forecast the temperature and humidity and plot the forecast in the dashboard. So let's start with cloning the repository. You'll find the link in the description. So let's copy the URL and from the terminal get clone that's it. Let's switch to VS Code. So that's our project. So after cloning, we will export the data from the database, but we need first to set up our credentials. So I'll just rename this file to .env, and I will change these environment variables to our actual values. So after setting this up, let's just run the export sensors data. This connects to our database and saves the data to a CSV file. But as you can see here, we still need to install the dependencies. So first let's create the valve. After creating the valve, let's do pip install. Oh, we need to activate it. Pip install requirements.txt. Here it will install all these dependencies. Now that the dependencies are installed, let's run our export sensors data file. Here is it. The data is exported here, and here we need to explore our data. It says the EDA notebook, just to get a look on what we have in the data. So that's how our data look like: pressure, temperature, humidity, and light, and keeping track where this was recorded. df info. Here to see the types, df.describe. We can see here the minimum of light value we have, the minimum humidity reached. This is a low humidity, actually 22. The temperature, min and max, also the pressure. So everything kind of looks good. Here we will check the missing values, which should be none, and duplicate timestamps. Maybe we get something recorded twice. Well, actually we do. We have one duplicate, which is manageable. It's not that thing. Missing timestamps. So we are capturing data each 5 minutes. So sometimes the server is off, so we are not saving the data continuously. And to better see that, we just take the range of the time we're recording the data and the frequency, which is 5 minutes. And as you can see, 31,000 expected readings, and we have only 10, so we're missing more than half of the data. Here just prints some of the missing timestamps. Here we can check the gap we have in our data. So the biggest gap we have is this, the 60 days gap. So the server has been shut more than 2 months, so we're missing 2 months worth of data, which is a bit problematic, but we will handle this in the cleaning. This is just more discovering what we have in the data. Like some days we only have one missing record, which is okay, not that big of thing. We can just interpolate. Here we can visualize the missing data. Well, this big gap, man, we missed a lot of data here. But anyway, here we can see the variation of the data. Most important values here or variables here are temperature and humidity. You can see here in February it was a bit cold, and we have a big augmentation in this month, May. This is just the distribution of data. We have 100%. Well, it's a city near the coast, so yeah, this is expected. Okay, here we can see the correlation between sensors. We can see the correlation between temperature and humidity is high, but in the inverse side. So the higher the temperature, the lower humidity is. This is our highest correlation in here. In the outlier check, we can here we define like what's the normal for our place where we recorded the data. -5 to 45. It's not normal, but just to be safe. And humidity 0 to 100. Pressure, that's the normal pressure to be there. And lights, this is the recordable with our sensor. So yeah, we have no outliers as expected. So let's save this and go to cleaning the data. Okay, this is the cleaning notebook. First, let's import. Load in our CSV. And for the duplicates, just simply drop in the duplicates. And here, since we had some records that were not really aligned, we had 0.02 in the EDA, like these values here. It's 2115, it should be 00. So just to align them, we run this. And here, instead of just having missing data, we just fill the rows with nonce for the records we missed. And in this part, we just separate the small gaps and long gaps. So for gaps less than 1 hour, we just do interpolation. And here we segment our data to continuous readings. So we end up with 4 segments of continuous data. And this is just to visualize the data we have, the segments. This is the first one of continuous data, the second one, third, and fourth. And let's save our clean data. This is the parquet of the clean data that we will use in the LSTM training. So for our LSTM, we will be targeting or forecasting the temperature and humidity and using all 4 features. So the window will be the records that will be used to forecast the horizon, which will be 12 records or 12 5 minutes, so it's an hour. Okay, let's load our clean data, and then we will normalize our futures. Training data normalization is separated from the validation data to mitigate information leakage. And after that we have the slide-in window in data class. So since we have a small data, our best choice here is to have a slide-in window. And in each iteration we will do a slide on one record. And after our data class, we initiate our training dataset and validation dataset, and also initiate the loaders. So we have 8,800 train windows and around 2,000 validation windows. And finally, let's go to model training. This is our LSTM. Those are the layers of the LSTM. So in total we have 31,000 parameter. And let's go to the training loop. This is a one epoch function that will be repeated in the training loop. We will be using Atom Optimizer and the scheduler to have a variable learning rate. So we will start from 10 to the power of minus 3, and 10 to the power of minus 5 is the minimum learning rate we will reach. And here, as we can see, the patience is how much epochs we will go through without having a better loss. So if loss is not getting lower after 10 epochs, the training loop would just stop. So let's run the training loop. Okay, we need to create this folder. So we actually got our best model on 11 epochs. So it reached 21 and there was no improvement, so we just take the epoch 11. And this is to visualize our training curves. We can see the loss going down gradually. And let's evaluate our model. So for temperature, it's pretty accurate. So the mean absolute error is 0.1, which is a good number, but it's only for 1 hour forecast. So yeah, expect it. If we go more than 1 hour forecast, we will get higher mean absolute error. And for the humidity, since the humidity can reach 100, so it makes sense to have a little more or a little big mean absolute error. So let's visualize the prediction versus actual. So this is the temperature, this is the predicted. So it's actually predicting more than the actual, kind of. But as you can see, the difference is not as much as the actual is 17.6 and it's predicting 17.62, and that's good for my use case, just doing it for fun. Well, let's save the model and use the model to do the forecast and visualize it in our dashboard. So I updated the dashboard from the last video, but to run it, simply stream let run dashboard.py. Here you see the temperature, comparing it to the last day. It's 0.9 Celsius higher than yesterday, and the humidity is lower. We can relate this to the correlation table we saw. The higher the temperature, lower the humidity. And this is the forecast. So it's forecasting for the next hour to just be around 27 Celsius. And the humidity to be just going a little lower to 74 from 76. And here we can see all the data with the gaps, but just to not see these gaps, man, do it for 1 week. You can see this continuous data, man. I hate these gaps. So that was it for this project. hopefully this is the last video on it, and I hope you liked the video. If you have any questions, I will be responding with pleasure, so thank you for watching.